Alright, today we are going to be doing section 1.8, which is on number lines. Our objective is to graph real numbers on a number line and to compare real numbers. Our warm-up is a review of 1.4. Remember, we're skipping around a little bit with the sections this chapter. So we need to translate each phrase into a variable expression. A number decreased by 5. Any volunteers? Yes, sir. N minus 5. Very good. A number decreased by 5. 5 more than a number. Jamal? 5 plus n or n plus 5. Either way would work. Commutative property. The quotient of 5 and a number. Lexi. 5 divided by n. Very good. So with division, our order matters. So if we see quotient of, we've got to go in the order they gave us. 5 over n. Or if you prefer, you can use the old school division symbol. Whichever one you like. Alright, on a number line, the point labeled 0 is called the origin. The origin separates the line into a positive and negative side. Zero is neither positive or negative. All right, integers. The set of numbers containing the positive integers. We would write that in what we call set notation. Oh, sorry. Turn my pen on. So we have got curly brackets, which I'm not great at making on here, obviously. Do your best. The positive integers are 1, 2, 3, and so on. All right, we're counting up. The negative integers, they go on forever in a negative direction. And then we got negative 3, negative 2, negative 1. So negative 1 is the biggest negative integer. And then 0. So the integers contain these positive numbers, all these negative numbers, and 0. So when we go to write the whole set of integers, I'm going to write mine below the line because I don't think I'll be able to fit it on the line. We put all those sets together. Bless you. All right, the point paired with a number is called the graph of the number. The number paired with a point is called the coordinate of the point. These are just some vocab words. Any number that is either positive, negative, or 0 is called a real number. We are asked to write a number to represent each situation. Then write the opposite of that situation and a number to represent it. So we got a lot going on here. You will have some like this on your homework, so I would make sure you pay attention. A temperature rise of 6 degrees. What kind of integer do we think would represent that? Keon.
Positive.
A positive. What number? 6. Good. A positive 6 would represent that situation. Okay. The opposite of rising is going to be a negative, but what would we call it instead of a rise? A decrease. So we would say a temperature fall or decrease of 6 degrees. And how would we represent that? A negative 6. All right, so we were just talking about 7.3 kilometers north. We would associate north with a positive direction. So the opposite of that would be 7.3 kilometers south, which we would associate with a negative direction. Now, of course, direction is usually somewhat subjective based on where you start, so I could understand some arguing that a little differently, but typically north, up, positive, south, down, negative. What about example 3? A wage increase of $15. Somebody new, or we'll go to the sticks. I just did on the last one. Yeah, I did earlier. Nevaeh! Wonderful. If you are getting a wage increase of $15, that is good news. That means you are getting a positive 15. What would the opposite situation be? Ellie? A wage decrease of $15. And how would we represent that? Somebody new? May? Negative 15. Wonderful. Oop, I can't really see that around that symbol. Negative 15. Inequality symbols are used to show the order of two real numbers. That should be of, not or. Order of two real numbers. The symbol that looks like an arrow pointing to the left, that means less than. For example, 3 is less than 7. That's how we would say that out loud. The one that looks like an arrow pointing to the right means greater than. For example, 7 is greater than 3. Complete the statements using a less than symbol or a greater than symbol to make a true statement. So on the first one, we are comparing negative 5 to positive 4. Kion, which one do we want? So we are using one of these two symbols. So is negative 5 less than 4 or is negative 5 greater than 4? Less than. So we use the less than symbol, which is that one. On example 5, if you are not sure which one of these is bigger or smaller, it might help you to turn them into a decimal. If you don't know how to do that with your, well, we don't have calculators. We're not supposed to be using calculators. Hopefully you know what these are as decimals anyway. Half, especially, that one's 0.5. 1/3 is 0.3 repeating. If you needed to work that out, you can take 1 divided by 2 or 1 divided by 3 to get those. Either way, at this point we should be able to determine which one is greater, which one is less. So I'm going to ask Tariana to help me out with this one. Or sorry, 0.3 repeating. So 1/2 is greater than 1/3. All right, on example 6, we have -10 and 1/10, or 0.1. Are you raising your hand? All right.
1 is greater than 11.
Yes, but this isn't 1, this is 1/10. Does that change your answer?
No.
No, it doesn't, because this is positive and that's negative. So if we read it from left to right, we read it flipped around. If we read it from left to right, we would say -10 is less than 1/10. If you were to read it backwards, it would read 1/10 is greater than -10. All right, number 7 is asking us to graph all of these numbers, -1, 2.5, 0, 7/3, and -3 and 75/100ths on a number line. Then list them in increasing order. Once you do half of this problem, the other half comes pretty easily. So let's graph them first, and then ordering them is going to be really easy. First, we need to set up our number line. So I am going to put 0 in the middle. And then I have my positive integers, 1, 2, 3, 4. I'm just going to go up to 5. And we have -1, -2, -3, -4, -5. So when we begin graphing them, the first one is -1. That one's pretty easy because I made a tick mark for -1. So I am going to put a point there. Make sure your points are an appropriate size, meaning if you have a number line here, if you just go boop, there's my point, that's not going to work for me. Okay, I cannot see that. Also, don't go and do something crazy like this. That is far too big of a point, right? Make it an appropriate size. It's my public service announcement about that. All right. So -1 was pretty easy. I can mark that one off. Now I have to graph 2.5. Who can tell me where they think I should put that? Lexi, you already answered. Would you like to answer again?
In between 2 and 3.
Very good. 2.5 is halfway between 2 and 3. So that is where I would put it. If you want to remind yourself, you can kind of like put a little number above it, like that's my 2.5. -1, obviously it's already marked, so I don't need to do that. You can if you want to. 0 is pretty easy, right? We've already got that one marked also. So I'll put a point at 0. Seven thirds. That one we definitely do not have marked. Since we're not using calculators yet, we can't necessarily turn it into a decimal. We can, however, think about it as a mixed number, which which I don't usually like mixed numbers, but in this case it's useful. How many times does 3 go into 7? 2 times. So we would have 2, and then we would end up with 1/3 left over. 2 times 3 is 6, plus 1 gives us that 7. So now that I have it as a mixed number, I should be able to know where that point belongs on my number line. Jamarl. I always feel like I say your name wrong, by the way. Where is the point going to go for 2 and 1/3? Between the 2 and the 3. Should it go between the 2 and the 2.5 or between the 2 point... Closer to the 3 or closer to the 2? Closer to the 2. Very good. So we're going to have a couple points very close together here. So we have another point in there, which is the 7/3. Okay, if you want to make a little note of that. So 7/3 would go between the 2 and the 2.5. If you don't get it exactly where it should go, that's fine, but you should have it in a reasonable place. All right, our last number that we have to put on this number line is -3 75/100. Anybody new able to help me out there? Connie, can you help us out?
Put it on the closest to
On the positive side or the negative side? On the negative side. So we're going to go closer to the -4, but it's in between -3 and -4. It's almost a -4, but not quite. All right, now we have to order them from least to greatest. Use your number line to help you. Don't go back up here. Look at your number line. Okay, so who can tell me which number I should list first? No new hands? Dylan, which number should I list first? The lowest number. Wonderful. The lowest number is going to be the one to the furthest to the left on the number line. So -3.75 is the least, the lowest. Which number should I list next? Yes. Wonderful. If I start moving towards the right, -1 is the next point that I find. Anyone tell me what comes next? Kelby? 0. Very good. We're just going in order. What number do I come across next if I'm ordering from least to greatest? Houston? 7/3. Very good. And finally, what's the last number I need to list? Natalie? 2.5. Beautiful. All right, that is it for our notes on section 1.8.